equations on, the first thing you always want to do is get rid of that double angle. It's your first step. And so, looking at this one, you want to get rid of your cosine of 2x. You have options on which identity to use, but since the other side of this equation only has a cosine, you probably want to keep this all in cosines. So choose the identity that has cosine in it. It'd be a 2 cosine squared x minus 1 is that identity. And then equals cosine x. I'm not going to probably do all these problems, and I'll get you started on them. If you look at what you have now, you have a squared term, you have a number, you have a linear term. This is a perfect trinomial factoring thing. We need to bring the cosine x over. And now you start doing your factoring, set them each equal to 0, and go from there. 15 and 16 are both similar because they have that number in there that's bigger than what we're used to seeing. But you're probably overanalyzing, overthinking this because these really come out super quick and super easy. Looking at 15, what you're doing on this is you're verifying this identity. And I think I have that written wrong. I think this was a 2x right here. Sorry. Okay. But I wanted to show you, if you look at what the identity is, over on this side, we have a 2 theta, because it is a double of whatever we use over here. So if you look at this right here, this is this exact identity. You've got the 2. It's just that instead of a theta, you have a 2x. Instead of a theta, you have a 2x. So we have the identity. What this would be the equivalent of is this right here. There's not much for me to do because just like these were thetas and this was a 2 theta, these are 2x's, so this is a 4x. It's really a one-stepper. You just go rewrite it. If I were to break down the sine of 4x using the identity, it would be 2 sine, and then 4x is a double of 2x. And it equals the other side. That's all there is. 16 is the same deal. If you look at the identity, how it's written, I'm choosing the one that has cosine in because that's what's over here. And whatever this identity is, instead of theta here, this is 2 theta. This is going to be double of whatever you have written here. So, if I have a 3x here, then this has to be double of it. Again, nothing to do other than just to rewrite it. So here I'm going to write my 2 cosine squared 3x minus 1. That's what it reduces down to. It equals the same thing. 27 was not in the picture that you sent me, but I remember we did this one in class, and it had something about there was a sine of 4x minus sine of 2x or something to that effect, and I guess equaled 0, and I think we were solving, not verifying, but you were solving, and what we said we needed to do is rewrite this one here, use the identity to replace it. Now I know this probably isn't the same problem, I'm just giving you the gist of what you would do. So that would break down to 2 sine, and a 4x is double of a 2x. So just using that identity. And then what I have is a sine of 2x in both of those. I would factor that sine of 2x out. And then I'd have a 2 cosine 2x minus 1. And then, remember, I'm going to end up probably setting a bunch of stuff equal to 0 here. I could set the sine 2x equal to 0, but probably first I need to get rid of the 2x and convert the identity. Oops. So you're going to end up saying, well, the 2 isn't going to matter. You're going to set your sine x equal to 0. You'll set your cosine x equal to 0, because those are both just equal to that. And then this here, I'd like to be able to set it equal to 0, except it still has the double angle in it. I need to get rid of the double angle. I'm going to have the 2 here. I'm going to use the double angle, and I'd like to keep it in one trig function, so I don't want to use the one with cosine and sine. Just use the one with cosine or the one with sine. I'll just stick with the one with a cosine. I'm replacing this cosine 2x with 2 cosine squared x minus 1. And then I'd still have the minus 1. And I got to clean that up a little bit. This 2 is going to have to get distributed. So it's going to become 4 cosine squared x minus 2. And then a minus 1. That becomes 4 cosine squared x minus 3. Now I have something that I can set equal to 0. I'm going to have the 2 sine x cosine x equals 0. And I'm kind of out of room, and I don't even know if this is the right problem or not, but like I said, we did it in class. I remember it being something similar to this. Set sine x equal to 0, set cosine x equal to 0, and set this quantity equal to 0. That's going to square root nicely. I think it's going to be like a root 3 over 2 or something, plus or minus, because you're going to square root, and it should come out nice for you after that. All right, hope this helps.